My name is Josh Mulligan, and in this video I will try to prove that the PSI to water column conversion factor is. So the conversion factor of it is 1 foot tall column of water exerts 0.433 psigs at its base. So the equation would be 1 psig equals 0.433 feet of water column, which would be 2.31 in this case. And here I will discuss the concepts and example problems in this video that I created beforehand. For 1 cubic foot of water to 23.1 feet of elevation, we will only generate 10 psi of pressure at the bottom, where we started, as opposed to the 62.7 pounds mass that we lifted up in the air. So let's take the knowledge that we learned and put it into practical use. Let's say we have a lake cottage on top of the bank and we want to know how much pressure a pump is going to need to push the water to the top of the hill. We don't have time for a surveyor or the money, but we still need to know the elevation change from the lake level to the cottage. If we take a garden hose or tube and run it up the hill, put a pressure gauge at the bottom, and then fill the hose or tube with water, we can tell what the elevation is on the hill. If the gauge reads 40 psi when the hose is filled with water, we know that the elevation is 92.4 feet. We simply take 40 psi times 2.31, which equals 92.4 feet. Now this is not distance, but feet of head. We may have run 1,000 feet to raise 92.4 feet, but either way, we will have 40 psi to overcome to pump water to the top of the hill. To illustrate the effects and relationships of head versus psi under static conditions, we must note several items. First, the amount of water with the same height will give the same pressure at the bottom, no matter how many gallons in the tank or the size of the pipe. Remember, we said not to confuse mass with pressure. The common elements in the head, which is 150.5 feet, and if we divide that amount by 2.31, we will come up with 50 psi's. These conditions are true for static conditions. If the water starts to flow, then we will incur friction loss, and for the same height of water, we will have less pressure at the bottom. For 1 cubic foot of water to 23. So here I used my experiment to test the conversion factors. So what I wanted to do was I wanted to see if I could get roughly 2.31 or 1 psi G. And from my testing, I realized that my pressure gauge probably wasn't going to be the most accurate. So instead of going from 1 psig, I went for 5 and 10. So that means I needed a lot taller pipe. So here you will see my materials list was PVC pipe plus connection adapters, water, and water pressure gauge, and a water valve to make sure my pressure gauge was safe. And here you'll see how tall it was. Yeah, don't ask how we got this tall structure up in the tree, but it was around 23 feet and like 2-3 inches, which is what we calculated should be enough to get roughly 10 psigs. So that was our objective with this structure I built. And then in this video, you'll see me filling it up with water and my uncle holding the rope while we basically tied and dragged it back up into the air with the water in tow to try to get an accurate pressure gauge reading. We did this test a couple of times to try to get out of some issues that might happen, so like water loss might, even if you try like with Teflon tape and glue, pipe glue, you can still have some water loss and certain issues that could come about. So we try to do this in a fast motion and do it a couple times to check it. And we found that we got really close to 10 on one, but the footage for it was deleted. So this one we got roughly around 9.75. but if you look at the gauge when we first got it, it was slightly under where 0 was. So I'm assuming it's gauge error, but we'll see.
Alright, no, that's good. Now get the rope. Get the rope in. Over there, go grab it. You got it? Yeah. Go grab it. Alright, wait. Alright, go. Just slowly. Alright, stop for a second. Alright, a little bit more. Alright. Go. Alright. Stop. Down a little bit. Alright, stop.
So you might be asking, does it matter that our structure wasn't straight? And no, or the size doesn't matter either. It's all about the height, basically. The height is what we wanted, and I measured it out in that first clip too, and it was the necessary height to get it. And we got roughly around there in this video. And so next, we will see my conclusion based off my data. So from the video, which my total length is 23.1 feet, the necessary length for 10 PSIGs, theoretically, I should have gotten 10, and I got roughly 9.5, 9.75 on a few, which I believe that was roughly due to my pressure gauge errors. And it's common knowledge that if I wanted to improve on this pressure gauge to get a more accurate reading for the water pressure, since I am using pretty small PSIGs, 10, 5, 1, all those aren't too much pressure in the real world. Most pressure gauges you buy at the store won't be as accurate, but the ones that would cost you several dollars. Pretty expensive, which is common knowledge because I was looking them up. And yeah, so I figured out that yes, I believe that pressure is right, and how the people calculated back then had a way more precise gauge than me. They might have used mercury to figure it out, because mercury is a good source to do rather than water to figure out the pressure. And thank you.